Hello everybody, and welcome to exercise 4 on page 88 of the workbook. Now let's read this question together. So they'd like us to find a group of the form this, and notice that that's just kind of the standard way of representing any finite abelian group. According to the theorem of this chapter, we'd like to find a group of that form that's isomorphic to U of 15. Okay? So let's talk about how we might do that. So a good first step would be to ask ourselves what's in the group U of 15. Okay, there we're just talking about all of the positive integers between 1 and 14 that are relatively prime with 15. Okay, so we can make a list here. We've got 1, 2, let's see, 3 is not going to work, 4, 7, 8, 11, 13, and 14. Okay, that's a complete list. And notice that this group has order 8, and it's abelian, okay? Because we're talking about multiplication modulo 15. That's certainly an abelian group that we're talking about. And so what that means then is we can use our theorem about finite abelian groups and say that this group has to be isomorphic to something of this form. Okay, we've got to be able to write it that way. And so what we'll do is to think about what are the possibilities of doing that for a group of order 8. Well, one possibility is Z8, Z of 2 cubed, or we could take that 8 and break it down into 2 times 2 squared. That would give us a group of the form Z of 2 plus Z of 4, or we could take the 8 and break it into 2 times 2 times 2, and the corresponding group would look like Z2 plus Z2 plus Z2. Okay, I'm kind of leaving it to you to convince yourself that those really are the only 3 possibilities. It comes down to the partitions of the number 3 because of the fact that 8 is 2 cubed. Okay, so basically what we need to do is to rule out 2 of the groups on this list. We know it's one of the 3. Okay, if we can rule out 2 of them, then we know what U of 15 is isomorphic to. We're going to do that through just a series of observations here. Okay, and I want to emphasize that the method that I'm showing you here is not the only way. There are a lot of ways you could go about this. This is just one of several different approaches that you might take. Okay, so what I'm going to do is to start with the element 2, okay, in U15, and just calculate its order. Okay, so if we take 2 to the first, we're going to get 2. 2 squared is 4. 2 cubed is 8. And then 2 to the fourth would be 16, but 16 mod 15 is 1. So in this particular group, 2 to the fourth is equal to 1. Okay, and so what we've convinced ourselves then is that the order of 2 is 4. Okay, but take a look at the list of groups up here. Z2 plus Z2 plus Z2, you can think about that and convince yourself that that group cannot have an element of order 4. The biggest order that any element in Z2 plus Z2 plus Z2 can have is 2. And therefore we know then that U of 15 can't be isomorphic to the last group on the list, okay, because U of 15 has an element of order 4. All right, let's see if we can put that into words here. So U of 15 is not isomorphic because all elements of Z2 plus Z2 plus Z2 have order 2 or less. None of them have order 4. Okay, good. So we have ruled out Z2 plus Z2 plus Z2. And we're going to make another observation, which is going to rule out a second one of those 3. All right. So I'm going to pick on 2 more elements of U15, starting with 4. Notice that if we take 4 and square it, we're going to get 16 mod 15, which is 1. And if you play that same game with 11, okay, take 11 squared, mod 15, you'll notice that that's also 1. Okay, so what we've just demonstrated with those 2 calculations is that 4 and 11 both have order 2 in the group U of 15. Okay, so what we know then is that U of 15 has at least 2 elements of order 2. Okay, but if you think back to some of the things that we know about cyclic groups, if you look at Z8, it has only one element of order 2. The only element of order 2 in Z8 is 4. Okay. So since Z8 has only one element of order 2, we now know that U of 15 can't be isomorphic to Z8 either. Okay, so we have just crossed Z8 off of our list. And so what's our conclusion here then? Well, if this is not isomorphic to Z8 and it's not isomorphic to Z2 plus Z plus Z2 plus Z2 plus Z2, the only possibility is the one that's left over, Z2 plus Z4. Okay, and that's our conclusion. Okay, and we're done.